Hey, this thing is on now. Hi, sorry about that. I hope there wasn't a horrible, horrible noise. I know there was one. My apologies. Only one mic pack was on the receiver. When the receiver is on, it makes a terrible noise, which seems like a huge oversight on the part of the design. Very sorry about that. There's a delay between the broadcast and the comments, so here come the comments. Ears exploding. Cooper, I am so sorry. And others. Yikes! Well, we're off to a good start here, but hey, let's move on. Let's move forward. This is the workshop show. This is my workshop. I'm John Park. This is John Park's workshop. Here we are. And what are we up to here today? Well, I've got a bunch of cool, fun, interesting things to show you and talk about, I believe. So let's prepare ourselves mentally and emotionally, shall we? So, first of all, I'll let you know I've got a coupon code today. I have a recap of the product pick of the week show. I've got a CircuitPython Parsec. There is a deeper dive into some of the WLED synchronization and audio reactivity stuff that I was attempting to get going yesterday. There's also a little bit of a tool tip today involving, this was a question I got yesterday, and I'm sorry I can't remember, or on Tuesday, I can't remember who asked this in the chat, about prying off stuck boards, almost like a socket when you've got picos jammed into a doubler or tripler. How do I get those off there? I'll show you the little trick I use for that. And I also use that on knobs, although I don't think I have a gizmo here with that kind of knob that I can show you that on, but I could do that another time. Oh, maybe I can demonstrate on one of these encoder knobs. These are pretty easy to get off, but yeah, I'll show that. That'll sort of pseudo work for that. Sure, let me put this over here as a reminder. So, first of all, coupon code. If you want to go to Adafruit.com and pick up some neat stuff and save some money, I've got a coupon code for you today. Today's coupon code is ZimZam. That's right, the backyard game of our childhoods, if you're from the 70s and 80s. That's ZimZam, Z-I-M-M. -ZAMM. Has absolutely nothing to do with any of the content on today's show, but I was just thinking about ZimZams. It's a tetherball game. If you don't know, look it up. And what that'll do, if you mark this code down or take a mental picture of it and then type that into the coupon code slot over here on Adafruit.com when you are checking out today with some cool new neat stuff, you will save 10%. So that's good on any of the things that we can put in a bag or a box and ship to you, an envelope. No software, no gift certificates, no subscriptions, but things that we can throw your way via a delivery service, that'll do. You'll get 10% off. If you're wondering, what should I get? Head on over to new products. There's a little link. There's a few different links for how to see the new products, such as new products link right here in the hamburger menu if your browser window is kind of smallish. And there you can see we got some neat stuff, including the Sparkle Motion stick and the enclosure kit. There's a bunch of those in stock. There's also just the bare stick down here somewhere. Did I pass it? Sure, right here. 4 of them in stock if you don't want the case. You want to print your own. You can pick up some neat stuff like those. You can also find out about free stuff. So if you go to adafruit.com, not /new, but /free, then you can see some enticements here. If you spend $99 or more, you'll get this free PCB coaster. If you spend $149 or more, you'll get the coaster and a KB2040. And if you spend $199 or more in the continental United States, you'll get free UPS ground shipping as well as the KB2040 and the coaster. So those are some freebies that you can get. But just dig through some new products or any of our categories. We've got lots and lots of stuff here. All categories, just go for it. Find some things you want and then type in the coupon code ZIMZAM on the way out. You'll get 10% off today. Hello to the chats, by the way. I traditionally do that, but I was so scared of the chats because I had just deafened you with my microphone mistake that I was too scared to go. I lacked the courage to go see what was going on, but I think it's going to be okay now. So let's check it out. We've got the YouTube chat. Hello to Dave Odessa and Beata Graf Avdelhagen, who has ice cream and a Blinken lamp assembled and operating. That's excellent. And Dave Odessa also letting us know they've got coffee and are ready to go. Hey, that's cool. The other chat, if you're somewhere like Facebook and you don't know where everyone is and who is John talking to, then I recommend you check out our Discord. That's our favorite place to chat. Honestly, it's where most of the chat is going most of the time because it's not tied to a particular show. But if you go to adafruit.com/Discord, jump into our Discord server and then look for that right there. That is the live broadcast chat channel, the one that's highlighted there. And you can see Todd Bot is showing off some jarts there. That's another great game of our youth. My sister and I had both jarts and Zimzam and no permanent brain injuries from either, which is amazing. Jarts are just big, huge, heavy, airborne and eventually landborne pointy things with fins that make them fly true, and they worried that they go right into your head, so they kind of got rid of those. But we've got Andy Calloway there. Hey Andy, nice to see you. Thanks Toddbot, good to see you there too. Cooper, hello. I am so sorry about exploding your ears in particular, Cooper. And who else is here? Sam Blenny. Hey Sam. Sam is doing some excellent I can't talk about it yet, maybe top secret work on a cool project that I just checked out. So, and if you haven't, go check out some of Sam's excellent playground guides. In fact, let's take a pause here for a second. If you go to adafruit.com/learn, or learn.adafruit.com, sorry, you can see we've got this playground section right at the top here. It says learn more. You can also go to adafruit-playground.com and you will see some terrifically cool projects. In fact, this one I'm looking forward to building. Oh, wait, I clicked your name. Go back to the, oh gosh, I'm breaking everything. Clicking doesn't work on that. I2C FRAM memory carts. Look at this. These are cartridges. They use the magnetic pogo pin connectors, and they add little storage, little cartridge-like memory storage to your projects. So I'll dive into this a little more once I build one, but Sam is up to cool stuff, so thanks for that, and thanks for coming to hang out over in the chat. Let's go back to the Discord. Who else is hanging out here? Thin Man, hello. Welcome. Thanks for stopping by. And that's people in the chats. Hey, C. Grover. A childhood rite of passage if you and your siblings survive. The jarts, and we had the mosquito zapper going all summer, which if you shoot a squirt gun at is not such a great thing. Zim-Zam, kickball, BMX bikes, all the fun. Gravel in your knees. That's summer. All right. So what else? I mentioned the Tuesday show. I have a show on Tuesday called JP's Product Pick of the Week. Sometimes it looks like that. And the product pick gets a nice bit of a demonstration, some info about it, a deep, deep discount, 50% off in the case of this one this week. And I like to provide a little 59-second recap, so here it is. The PyCowBell Ada Logger. It is for logging your data. It has a micro SD card over SPI. It has a STEMMA QT port for attaching sensors, and it has a real-time clock with battery backup. Got the Pico 2, I've got the Ada Logger. You can see I have the coin cell battery in there. I have STEMMA QT plugged into an SHT45 humidity and temperature sensor, and then I've got my little SD card plugged in there to log data. Every 30 seconds you'll see a little LED light up on the Pico. Oh, it just went. It means it just wrote some data. Looks something like this plotted, in this case, inside of Google Sheets. This is a few hours. I had this running overnight. PyCowBell Ada Logger with real-time clock, micro SD card storage, and STEMMA QT connector, all in a neat little Pico and Pico 2 flavored package. Yep. All right. Next up, I'm going to prepare for a CircuitPython Parsec. CircuitPython Parsec. Hey, thank you for the notes. Everyone just said bing, bing, bing. I forgot to flip that little switch, so it's audio mayhem here today. All right, let's start that over again. For the CircuitPython Parsec today, I wanted to show you how to do an analog read using the Seesaw chip over I2C. So we are continuing the series here on having GPIO that is local to the little board, and then Seesaw chip sending all of its little reads that it does over I2C to your microcontroller. In this case, I've got a QtPy RP2040 running CircuitPython, of course. And this is, again, this little gamepad Qt board, which has 6 buttons on it, and we looked at some digital I/O stuff last week. This time we're going to talk about this little thumbstick, which is a set of small potentiometers. You know what, let me just turn up the exposure on that camera. There's no reason for it to be that dark for this here today. There we go. Looks like it's in focus even too. Okay, so what's going to happen here is we're going to import Seesaw so that we can do all that little local stuff as well as send those messages over I2C. I'm setting that up on the STEMMA I2C bus, and then I'm creating the Seesaw object by saying Seesaw I2C bus, and then the address of the Seesaw chip bearing board. In this case, address is 50. Now, the next thing that I'm doing is just printing out a little information to the REPL and setting a state variable for the X potentiometer and the Y potentiometer, which is what's inside of this little tiny thumbstick here. Then for the main loop here, what I do is I set this variable X to be equal to 123 minus the Seesaw analog read on pin 14, and then 123 minus the Seesaw analog read on pin 15. So those are pin 14 and pin 15 analog potentiometers, but this would work with any analog thing that you're trying to read. Then we just check for a little bit of a change, as long as, just so it's not too noisy, as long as the reading that we get is 3 away from the last state on last X and last Y that we checked, then we'll go ahead and proceed with outputting the little string format here. So this is setting up a nice string that I can print to the REPL without my REPL flying by. That's what this jazz is about here. And then the X from this X read with 4 digits and the Y from this Y read with 4 digits is going to get printed, and then this little escape character /R keeps that all on one line. And then after we've done all of that, read, print, and then set the new baseline to the current position, and a little tiny sleep there. So you can see here at the very bottom of the REPL, it says 0 if I go far left, 123 if I go far right, and around 512 or so in the middle. And then up is around 1024, and down is around 0. So you can see just moving this little, they call it a thumbstick, I should use my thumb on it. Moving this little stick around, we get the analog read. However, there's no GPIO being used on the CircuitPy. Instead, we're getting these over Seesaw. Now, in this case, that's not a ton. It's 2 GPIO pins. However, when we go ahead and add in all of these 6 buttons here, we can have some nice efficiency. Oh, I just blew it up by pressing one of those buttons. Let me restart that. We can have some nice efficiency by doing the reading off board on the Seesaw chip, which is prepared for all this GPIO, and send that over I2C, which means we've left the sort of minimal number of GPIO pins alone on the CircuitPy. So if these are plugged into a whole bunch of other stuff on your project, we've now saved ourselves about 10 different GPIO pins or so using Seesaw and I2C. And that is how you can do an analog read using Seesaw inside of CircuitPython. And that's your CircuitPython Parsec. All right, that time I just left the microphone on. That might have been echoey, but I have bad luck today with turning that on and off. Hello, also over in our YouTube chat, thank you, Joe Clar Music, who also mentioned no audio. I got a lot of thank you. I do appreciate getting the input in real time, because when I hear ba-doop, ba-doop, ba-doop going off in the different chat windows, that wakes up part of my brain, and I go, hey, wait, something's up here. Maybe it's the microphone. It's usually the microphone. Okay, so let's close that down there. I'm going to set this off to the side. By the way, this little thing here, super useful. You can also get, I think we have 400 millimeter long I2C cables, so I've used that before as basically a little gamepad plugged into a microcontroller with a TFT. They're kind of neat. Obviously, they're a little on the small side, but that one, I can't remember if I've shown the specific product here. This is it. Actually, this is the Learn Guide for it. That's what I've been using there. So I think this one was based originally on a Raspberry Pi bonnet, the Joy bonnet. I think that was maybe what came first, and then this was the sort of simplified version. And I believe that one also may use essentially a Seesaw chip, because Raspberry Pi, I don't even think that has analog inputs, if I'm not mistaken. So getting the analog sort of breakout there is super helpful. And let me show. Yeah, some nice says, I love the REPL output on a single line. Yeah, the main thing there is that friend of yours, which is comma end equals quote \R, and that'll repeat it on that one line. So yeah, there it is. That's the little gizmo I've been using there. Have I ever done that one on the product pick? Yes, I have. Those are really neat. So that's what I've been using. And it's got some holes, little mounting holes there, so you can attach it to like a swirly grid or something else if you want to make it a little easier. Oh, and Toddbot mentions, thank you in the chat, that you can use up to 4 of these because we have enough address jumpers on the back. Where did I just put it? Here it is. We have enough address jumpers on the back there to do 4 different I2C addresses before you'd have to start doing muxing. So if you want 4 different I2C addresses, you can use up to 4 of these. So you can use up to 4 of these. So if you want 4 different I2C addresses before you'd have to start doing muxing. So if you want 4 different I2C addresses before you'd have to start doing muxing. So if you want 4 different I2C addresses before you'd have to start doing muxing. So if you want 4 different I2C addresses before you'd have to start doing muxing. So if you want 4 different I2C addresses before you'd have to start doing muxing. So if you want 4 different I2C addresses before you'd have to start doing muxing. So if you want 4 different I2C addresses before you'd have to start doing muxing. So if you want 4 different I2C addresses before you'd have to start doing muxing. So if you want 4 different I2C addresses before you'd have to start doing muxing. So if you want 4 different I2C a really small, I don't know, Smash Brothers clone. Try it. Okie doke. Next up, what have I got? I think I'm going to do this little tool demo over here just because I ended up setting up a whole situation on the workbench for the WLED project. So I'm just going to move this over here and show you my little tool tip. Did anyone remember who asked this question just a few days ago or last week, I think, about, yeah, it was probably on Tuesday, about pulling these boards. So let me get this a little focused. And I'll point the light over here for a second. That's a very blue light I pointed, so there we go. Okay, yeah, so you can see that a little better. So the question came up about how to safely pull something like a Pico, which has 40 tenacious little header pins, out of something like a Pico doubler or tripler. And this one, in fact, the doubler and tripler, they come with the short header pins, so this is not as bad as it can be. But when you're using something that has the regular length headers, sockets, and pins, it's a bit of a pain to get off. You can go in here and wiggle back and forth, and the main problem I have is when one side lifts first, these back legs invariably get a little bit bent, which isn't great. If you're doing it once in a while, it's not a problem, but you don't want to stress them out that much. It'll probably also stress some of these solder joints up here. So the trick that I've come up with is, if you've got these on hand, I don't know if I would run out and buy some for it, but if you've ever gotten some iFixit kits, you've ended up with some of these little prior bars that are like a little plastic pry bar that's meant for opening up the sides of, you know, iPhone case or something like that. And since they are plastic, that's good. They're kind of a little slightly softish plastic, and they have a just a little bit of an angle here that you can rock them on. You can fit them up under and start prying. And in some cases, depending on the board and what I'm trying to do, I'll just put one on either end, and there you go. Just to give it a little gentle pry. It's easier if it's on the, just a little gentle pry. That just means that we're coming up from both sides at the same time. This is, here's the board I was showing on Tuesday, which led to this question. This is the data logger. And I think maybe I got short header pins on that one. So again, we can get in there. You want to be careful. You don't want to crush our little port there. So you can come in from this side and then this side. You can work your way towards the back, but even better, work it from both sides or do both at once, and that'll lift that off enough to pull it. The other thing is that I end up using these, and this is a bad demo that I'm about to show you because this is a weird mounting for this, but with knobs for potentiometers and encoders that are on the fronts of panels, particularly audio equipment, Eurorack synthesizers is where I run into this a lot. These are the best for this problem because you will end up with ones that are like really difficult to pull. In fact, this one is. This one's actually really difficult to pull up there. You don't want to go wiggling your potentiometers loose and breaking stuff, hurting the shafts. So if the faceplate is on, it's going to lie here somewhere around, let me get a little closer and refocus. The faceplate would be somewhere around here, so we get a nice surface to pry against. I'll sort of pretend here this won't work as well. But you can see just by, I'm using my fingers as the leverage, but boop, like that, they pop right off. Shoo. Doesn't seem like a big deal, but when you've got 12 knobs on a thing or a whole panel's worth of stuff, and you're popping knobs off, which is usually necessary to then get to a nut, which you'll use your 10mm socket that you haven't lost and put a little blue tape on it, pull that nut off, and then you can pull something out of its faceplate. So those are my favorite uses for these. In fact, more than prying open iPhones is getting knobs off and extracting chips. You can use things like chip pullers, I guess, if they're the right size. This kind of chip puller, but this one's not that high quality, and it's metal, and it requires grabbing and yanking, which is not as easy to do gently as this little prying up motion that you can do. VP Tech Ops says, I use the handle of a disposable plastic knife or spoon, just insert and then twist. Excellent. Yeah. So use what you have on hand. Like I say, you don't need to run out and buy something for this, but if you have chopsticks, something that looks roughly like this, you can usually feed them in there and wiggle. Let's see. Oh, David Essa says you may be able to 3D print those pry bars. That's not a bad idea. Is look and see if anyone's made a 3D model of those or something similar. Small. You want a small crowbar basically, and plastic is probably the best in this case. All right, so that's the little tool tip I wanted to share. And thanks again to whoever asked on Tuesday. I don't think I can scroll back on Discord far enough to easily find it right now. Paint can opener, yeah, that's roughly the right, just put some tape around it, some painter's tape around it. Spudger, yeah, these are sort of I think they're a form of a spudger. I've got one of my iFixit kits over here. I've stolen all the spudgers out of it, and now they're somewhere scattered around the workshop. But yeah, I think of, well, I've lost all the spudgers, so that's not going to do me any good. These aren't that far off from a spudger. I think of a spudger as like the flat thing, and these, they kind of specifically made them with a little prying action to kind of work them inside of stuff. But maybe they're spudgers too. All right. Let's see. Tyeth, was it your question? It was. You're going to have to rewind. But my answer was, here, I'll do one more quick demo. That was Tyeth who asked. Thanks for the reminder. All right. Quick live demo for you, Tyeth. This is 2 of these little pry bar guys. Here's something like the issue we had, which is a Pico, which has so many pins on it that you're really going to want to bend these end ones if you're not careful. Excuse me. I'm going to sneeze. In some cases, just putting something like these, one on each side, and then prying up at the same time, wiggle, wiggle, and it comes out, and you don't bend that end. So, and there are some good suggestions over in the chats for things like disposable plastic knife or spoon. Put it in and twist. I like that one. Maybe a paint can opener. Maybe 3D print some stuff like this. If you know of a good other tool, there's probably something even better for this, but there's what I do. All right, so next up, let's get back to this light over here. Let's get back to the LED platform shoes project, which I called it Sparkle Toes here. Sparkle Toes 2 Electric Shoegaloo. Made myself laugh with that one. So these are platform shoes that have a space and an actual lid in the toe box to fit. It's about space like that. Super high heel. This is for a drag artist I know, and they wanted to get sound reactive and motion reactive LEDs inside of the two shoes. So last week I started on using WLED and a couple of our Sparkle Motion minis. You can go check out last week's show to see me get partway with that and then fail to get synchronization. But I figured it out, like moments after the show ended, in fact. Motion Mini. These are what I'm using. And last week I was just trying to get two of them to sync with each other. I've got that working, and now I've also enabled the microphone that's built onto these. So WLED has some different provisions for microphones, digital I2S microphones, analog microphones, and you can go through some settings and pick them. In the case of the Sparkle Motion, it doesn't have to be an external one. It can be. I don't think I have it here, but we have little PCM microphones with a JST connector that looks an awful lot like our same one we use for I2C. So the larger beige connector on there, you can plug in a mic, especially if you want to get the mic outside of an enclosure. But what I found with these, and I demoed this last night when Liz was hosting Show and Tell, and I'll show it again, is these mics work really well even enclosed inside of a Pelican case. I have a clear Pelican case, which I think is a good simulacrum for the shoes, which I don't have yet. And so we're able to synchronize the animation of the LEDs to music, and it's not just a power loudness kind of, volume kind of reactivity, but it's also frequency. So kind of like a FFT under the hood that allows high frequency stuff to ping one color, low frequency stuff another, and something else in the middle. So all of that works really well with these, and that's the foundation for it. What I wanted to do is head over here to the workbench and show you how I got these working. Show you some of the settings behind those in WLED. And you can see here I actually have my AC running, or a fan running over there, so you'll see a little bit of noise, but otherwise those are just lighting up when I speak, which is cool. The mics are over there on the workbench. And what I found is having the two of them each with their own mic but synchronized to each other as far as color and animation goes makes them very reactive. So if there's any differences in them right now, it's probably just because one mic is a little bit closer to me or something, but they essentially are in really nice locked sync, and that is not the case with sending messages from one to another. There's a little bit of delay I found if it's over Wi-Fi, if I send a message to one and it relays it to the other, and there may be tuning tips for getting that better to work better, but what I found is just even though you can have, I think you can have one with a microphone only and it's sending the animation messages to the other one. This works even better, and because these are going to be on some shoes, I want motion on one leg or one shoe to maybe trigger stuff even if the other one isn't. So I think this is going to be the way to go. Let me step over here and get set up. Excuse me. Oh, Cooper, I missed your message before. Maybe you could create a baby 4-player Teenage Mutant Ninja Turtle arcade cabinet. That's excellent. I love that. All right, let me log in here. So I've got my, just so you know what I'm doing, I've got my MacBook over here, and then I'm sending to an external monitor that's just sitting on my workbench so that I could show these as I'm showing settings. And what I'll do is, let's go to WLED. I think that's pretty legible. Let me know in the notes if you think there's anything. It's kind of a balance between exposure that shows the display and exposure that doesn't overexpose the lights. So in fact, let's try this. I'm going to lower the brightness of this one. And just so you see what's happening right now, I've got a strand of 20 NeoPixel RGB LEDs connected to a Sparkle Motion that happens to be in a little cute case, and then an insanely short USB cable that came with a controller from 8BitDo, plugged into my favorite little 3000 milliamp hour LiPo battery pack. So all of that I think will fit in the shoe, and it fits inside of my little test case here. I'll show that later, but for now I'll just leave it out. And this Sparkle Motion is on my local Wi-Fi. Oh, sorry, I've got the wrong main cam picked over here. Let me just switch to this. There we go. And so, since this is an ESP32 inside the Sparkle Motion, it can be on, and kind of needs to be on Wi-Fi to do some of these settings things. And then this is a completely separate Sparkle Motion over here. Same type, Sparkle Motion Mini. You can see here I've soldered on some little JST connectors, but in the end I'll remove that and get these wires on there directly. I don't want any of these black and red and green wires in there. I want it to look nice. And each of these can be found on the local network Wi-Fi with their own IP address. This is the one I'm connected to over here. So I'm not ganging up controls. I'm only talking to this one. However, this one is going to send any messages, any changes to it essentially that I click in the interface over to this one here. So for a simple demo first, let's just drop the brightness. So that should get them, yeah, you can see they're quite dim now. I'll bring that up. Dump, bump, 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 bump. And other thing to mention is that, like I said, these are both loudness and frequency. So if I whistle something high pitched, you should see these, I think, go green. Oh, sorry, pinkish. And in my sort of range of my speaking voice, it's in this blue. And if I make a really low sound, I think it goes green. No, it doesn't. Okay, maybe that was a different. Oh yeah, I switched which color set I'm using. But let's. I think that's a good brightness level there. Let's go ahead and set this to a solid color. So again, I'm just talking to what I'm calling the right. This will be the right shoe. So I set that solid, and you can see now both of them are solid, and they're just going to be based on whatever color wheel setting I send to this first one. So if I set this first one to green, they both are green. If I set this one to blue, magenta, and I can't actually see. Whoop, I hit a funny button on this mouse. I can't see the lag, which is a good thing. But it may be more obvious if this were trying to do the audio sync thing. But anyway, that sync, that is what I was trying to get to work last week. And here in the config is where I was trying to make these changes. And there was one button I didn't click. That is what I clicked after I shut down the live stream, and suddenly it worked. And that was send notifications on direct change right here. I believe if I had done playlist stuff, we would have seen the syncing. But since I was just testing it by clicking the color wheel mostly, or changing the animation effect, that is part of this send notification on direct change. So that was the key thing there. So if you want to watch last week and then jump to this part, you will have a complete story of how that came to be. Backing up a little bit, I'll show some of the steps involved. So first of all, Wi-Fi setup, ShopNet, that's the workshop network, and they are both on that. click back here. Normally you'd click save and it'll write the settings to the board. That's something that you would do one at a time. So you can plug in both of them and then just have two browser windows open and talk to those. The sync interfaces, we have sync groups. So you can have multiple of these in an environment and not end up with sort of cross-contamination of the messages by breaking them up into 8 different sending groups and 8 different receiving groups, which is wild. That means you've got a lot of complexity available as far as your setup goes. I've kind of told it to receive or send every possible command that's in here. So brightness, color, effects, palette, segment options, and bounds. So that's things like if you've got a 300 LED strip and you want to segment those into logical strips, if the physical strip is 300 but you want it to be 3 100 segment long things or something like that, you can have that information be just local or be a sent or received message. And then sending, enable sync on start. So there's a button up at the top that allows you to turn on and off sync. And I should mention, most of the time I've been doing this on my phone. You can do this from the web page as well, but the phone is normally where I would be so that you don't have to worry about having a whole computer. So sync on and off. If I turn off sync right here, now you can see when I change, let me move this battery. When I change the color of Miss Right Shoe here, Miss Left Shoe does not get that message. If I turn sync back on, it says other lights in the network can now receive them. And so now the messages that I send to this get sent to that. Oh, NYC Kid says over in the chat on Discord, matching them would be fastest to do with a third controller board, send the control signal to the shoes, would eliminate audio overload from walking, dancing, backflips, or sync with a time code of sorts and delay the sending shoes displaying of the code by X milliseconds. Thank you. That is an excellent, excellent bit of advice, excellent point. And I definitely was thinking about that if the microphones got too muffled inside the shoes, or if walking and things like that were causing too much trouble. So I definitely will consider that. Thank you, NYC Kid. If having one on a belt pack or something like that somewhere else, or doesn't even, it's a performer in a small space, so it wouldn't necessarily have to be on the performer, which is could be nice. So let's continue on. If we look back at config, so the sync interfaces here, enable sync on start, send notifications on direct change. That was the one that I needed to enable. In fact, let's turn that off and save. So that just told this one, don't send direct change messages. And even though it's set to sync, it's not going to send direct change messages. I won't try to set up a demo right now of using a kind of playlist over here, but I believe if we had a playlist that every 10 seconds moved to another animation, I believe that information would get sent, but not these kind of direct change things that we're doing over here. So I'll go back to config, sync interfaces, send notification on direct change. Button press or IR, I'm not doing either of these right now, but that if you have IR receiving, our bigger Sparkle motion boards have IR receiver built on. These ones have a port for it, sort of a little 3-wire port, I think it is, and you could do IR stuff, and again could say, okay, I want to point at one receiving, and then it will send to anything that's on the receive groups that it's synced up with. NYC Kid says, videos of her show when it's done, please. You bet. She better, because she's an amazing performer, and so I'm definitely going to try to get photos and video of these in action. And I should also mention, she's a friend of mine from, I do aerial circus. I do a discipline called straps in aerial circus, and we know each other from that. So she incorporates some aerial circus straps and some pole dancing stuff, and some amazing dancing into her act. So I feel like this is something I've been wanting to do, was somehow get LEDs involved with aerial circus stuff, and this seems like it might be a good way to do it. VP TechOps says, I think you can also sync using ESP Now as the protocol, so you don't need to join a Wi-Fi network. Thank you. I don't know anything about ESP Now, and I've just seen it mentioned in here. So if you have info about that, I'd love it, and I'll look that up and look into it. I'm presuming it's some sort of like direct messaging that they can do with each other without needing a hub, a Wi-Fi hub. But let me know if that's the case. This I can turn off, send Philips Hue change notifications. I kind of probably should turn off things that aren't part of it just to make everything as efficient as I can. I don't know anything about, I've seen mention of the UDP, receive UDP real time, and I'm not sure what that setup needs to be. I think someone mentioned that having that turned off on the router could have been an issue, but these are all way deeper settings than I've dug into yet. Oh, and we've got network DMX stuff. I'm not using DMX in this case. MQTT stuff, some Philips Hue stuff. All right, so I'll hit save because I think I changed at least one thing. And this is, I really like this little reality check here before we get into effects and animation, is just, can I send a direct color change from one to another? And then audio reactive stuff. So if we go over to the configuration again, and you can see, by the way, this mode on the web page is called PC mode that I have turned on. That is what the mobile version usually looks like, is kind of one page per thing. So we go from colors to effects to segments to presets, which makes total sense on a mobile device. PC mode is presuming you've got a bigger display. I don't know if that's available in the WLED Connect or Direct, is that what it's called, on iPad, because that, like a horizontally oriented iPad would work pretty well, I think, for this. But just so you know, the interface is usually a single kind of page thing, which is why this config looks the way it looks. When we go here, this is clearly a mobile interface that's just showing up on a PC. So user mods is where the audio reactive stuff lives. So when we click on here, you've got a whole bunch of neat stuff that are user add-ons to the project, including I2C GPIO hardware choices, SPI hardware choices, audio reactive, which is what I'm using. So I enabled it, and I clicked add palettes, which, I don't know, that sounds good. I have no idea. I mean, does it just do what it says? Sounds like. I didn't notice different palettes, but probably. If you have insights on that, let me know. I should ask Aaron. Analog mic, if you're using an analog mic, you can pick the pin for that. If you're using a digital mic, which I'm doing, and that's this onboard on the little Sparkle Motion, you pick the type of mic that it is, and this one is the SPH0654. You say which pins we're using for I2S. So this is the word select, data, and the clock pins, 9, 10, and 23. Once I set that up, save and reboot. I think there's an option for reboot after save here, which is helpful on this page. If you click on that, you can hit save and it'll automatically reboot, because some of these won't survive or won't show up until a reboot. Once that's set up, we can play around with configurations for automatic gain control. I have it on Vivid, which Lamore recommended. Lady Ada said, hey, try Vivid. It seems to work really well for this kind of music stuff. You've got some different algorithm choices here, if that's the right word for it, for the frequency scaling. And again, I think that would just be trial and error. There's probably deeper settings that you can access, especially if you're willing to monkey around in the configuration files for it, I'm guessing. But these choosing between no scaling, amplitude linear, square root energy, or logarithmic loudness are some choices for that. I want my high notes to do one color and low notes to another kind of frequency mapping. Dynamic limiter, you can set the rise and fall in milliseconds here for volume-based effects. That doesn't work on the frequency effects. So I don't think I changed anything there. I'll leave that alone, but enough talk. Let's do a little demo here. So if we go into both of these having audio reactive setup, since I'm not sending audio reactive messages, I'm just letting them both do their own mic thing. However, what effect mode we're in, what color palette we're using, all of that I can just change on this and send over there. So in the effects page, if you're not in PC mode, you'll go over here to effects. If you're in PC mode, you can see there's the effects. There's a bazillion of these, and some of them are just not audio reactive. So here's a blink. There's little icons here that tell you can pick a color palette for this, and there are little sliders that show up at the bottom for things you can change. So we can say, I want a slow effect speed, and I want a high duty cycle. Fast effect, short duty cycle. So those are the only changes available on that particular effect, blink. And then over here in color palette, there is, there's the color wheel and the HSV or brightness and Kelvin temperature sliders here. There are some preset things here. Then there's these two slots. Select your effects slot and your background slot. So in the background slot, you can do things like say, hey, when things are off, actually have them be red. So now my blink is returning to the state of that background color. So I'll make that black, that's off, that's a little more traditional blink. And then the effects slot here, you might be able to just do a solid color on this one. No, this one wants a palette. Okay, so select slot, and then we got to scroll down in here, and you can also do some search if you know the name of something, and pick. So here is a greens and blues. Here's a greens and magentas with some blues in the middle, like an aurora, and on and on and on. So here's orange and teal. I like that. So that's, again, only being set on the one, and then it messages the other. So you can see that those work pretty well. For audio reactive, you can go into search, and you don't even have to type anything into the search, but what you see up here are some icons to filter. So you know what, I just want to filter by stuff where volume and frequency, or volume or frequency, I should say. So if we go just to volume, now all of these have in their icons here a single music note. So if we do, how about, I don't know, pixels. Boop. Boop, boop. So that's picking up a little bit of noise from my, probably just the wind, honestly, coming from my fan over there. And since this one is inside of this little 3D printed case, this one's always going to stay a little lit. Kind of protect it from the wind there. So that's kind of neat. And then you can see it's reacting to me talking. If I instead go to some of these frequency-based ones, here's DJ Light. DJ Light does not have a color palette to pick, so it's built into that effect. So you'll find that some things give you more settings to adjust than others. But you can see them doing a little audio reaction there. Some of the ones that I've been liking here are this frequency pixels. So boop 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 boop. Ba 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 ba. So ba 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 is this orange color. High stuff is this blue color, and that is based on what selection you have over here in the color palette. So this one's orange and teal. So if we go, How about to rainbow? Woo! Wow. So it looks like yellow is at the high end of the frequency, and whoa, down in this purple blue area is at the bottom end of that, at least what I can do with my voice like that. What I thought would be neat would be to turn on some music and watch them, and I'm going to actually set the mics a little closer to my speakers there so that I don't have to blast it. But I'm going to turn off my fan there just because that's definitely picking up on there. Calmer. Nice. Okay. And now here's a little Bartle Beats song. I'll turn the brightness up. And now I can pick different color palettes. You can see it was green when it was just that little fluty riff. You can set up custom palettes as well, which I have not done in a long time, and I don't remember how you do it, so I won't pretend to know or try. But let's get back up here. Oh, okay, so here, yeah, I'll try this one. Let's try just colors 1 and 2. So in this case, background color becomes one of the two, and foreground is the other. But those are not animating, so maybe I can't use those? Question mark. Huh. All right, yeah, I don't know what's going on with those. Oh, let me get background out of. There we go. Background will pollute palettes, so you kind of want that to be black. All right, yeah, so that's it. Let me pause the music here. Thank you, Bartle Beats. And whoops, oh, I've gone big. Can I get out of that? Oh, come here. Whoa, there we go. I think that covers it. Yeah, so the key things there were just figuring out some of the settings on sync, and then setting up the audio reactive. Now, I'm going to head back over here. I'm going to turn back the fan because it's getting hot in here. There we go. I will show you one note on audio reactive and installing your WLED in the first place. So if we, there we are. If you head over to install.wled.me, plug in your gizmo. It doesn't have to be a Sparkle Motion. A lot of different ESP boards will work. You can check out on the internet some of our Learn guides, especially some of Aaron St. Blaine's guides. But with your board plugged in, you will connect to it over serial, over USB to the browser, and then pick a version of the software. Sound reactive on a lot of boards doesn't work in this version 15, this current version 15, and you have to drop back to 14, I think, 0.4. The Sparkle Motion Mini is a very particular cut that you need, which is ESP32 bootloader version 4 WLED 16 alpha. Sorry, so yeah, it's the 16 alpha. So coming in 16, I think audio reactive stuff's getting fixed. All that info I found in our Sparkle Motion mini guide. So if you go to learn Sparkle Motion mini, and did I just try to do that in Scottish? If you look at WLED setup, WLED software, this covers, it's kind of a templated page we have that covers a bunch of different boards. Here's the little call out on Mini. To get mic support now on this guy, download that. And there's a link on using our ESP web flasher, which is this here, the ESP tool. So I plugged in my Sparkle Motion. I couldn't get it connecting. I realized that I had my REPL open over in Z and shut it down. This will also happen with Cura slicing software and a few other things that you may have running on your software. And those will hog the serial connection. So make sure you've closed your serial connections and maybe replug the board, erase it, and then in the first programming slot, pick that downloaded file that you've unpacked. It'll come as a zip. You'll unpack it as a bin. Hit go. Wait 2.5 minutes. It will write it. It's probably faster than that. Reset the board or power cycle it, and now you have a version on there that's good to go. And then you can follow the usual steps to setting up. It will immediately create its own access point that you can point your phone at and then tell it your local Wi-Fi settings. Or, as I'm really excited to learn more about, I think it was VP Tech Ops in the chat who mentioned this ESP Now protocol. I like that because deploying anything out into the world and not having Wi-Fi and not having Bluetooth reliance makes me really happy. So if it's a direct connect without hubs and stuff, love that. Very, very good. So yeah, peer-to-peer protocol. Okay, thank you, VP Tech Ops. I will look into this. Appreciate it. Sounds like you're knowledgeable on these matters. So any tips you have would be super welcome. I can't finish this without pointing us at the shoes. That's the shoes. I don't know which height, but these have a little flap in the insole. I believe non-treasure ones could probably just be modified with some cutting to make a little trapdoor, but these have kind of a trapdoor built into there that you can put stuff, and that's where I'm planning to put all this stuff. And I think, as I showed yesterday, my little test scenario proof of concept was a clear Pelican case that seems like it simulates it pretty well, as long as I can tuck all the stuff out of the way. I just removed the rubber liner and gasket kind of all in one so that I could see it from both sides. Boop, 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 beep, 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 boop, boop, bow, bow. And tapping, which may or may not be what we want, so I'll look into that sort of third one as the speaker sender. But anyway, that's my simulated shoe. I don't have put that on my boot. That's as close as I'm going to get today, but we'll get there. And that's what we have to look forward to with our sparkle toes, which I don't think I'll end up calling them that, but that's it for today. All right. Hey, it's about time. It's about time to finish this thing up. Thank you so much for coming by the workshop today. Thank you for all of your tips and tricks and advice on some of this WLED stuff. Mike Jones said, like to see those lights incorporated into your trapeze circus act. Say you're sitting in the crowd and you change the colors according to the mood of the show, maybe in the audience. Heck yeah. Love to be the light guy for a trapeze artist. That's cool. Good. Yeah, good call. So, yeah, Tyeth also said ESP now is peer-to-peer with Wi-Fi frequencies. Can be run very long-range, low bandwidth if desired. That's exciting. Spicy Ramen Co. This is going to be amazing. Heck yeah. All right. I think we'll end it there. Thank you so much for hanging out and participating. Toddbot says, next live stream, I better have the shoes so I can model them. Yeah, I can probably stand on the workbench there. So I'm going to hit that camera. Maybe I'll get some in my size. So before I go, I will try to both remind you of the wonderful sport of Zimzam of our youth and let you know that that is a coupon code. That'll save you 10% off in the Adafruit shop today. Just type in Zimzam, Z-I-M-M dash Z-I-M-M, Z-A-M-M, Zimzam. In the coupon code slot, you'll get 10% off. This was not sponsored by the good people of Zimzam Co. or Hasbro or whoever the heck made that thing. I don't know. And that'll be it. I'll be out next week. I am out on vacation Tuesday through Friday of next week, so you will not see any live streams from me. I'll be back the following week, so enjoy a little bit of time off, and you will have some other shows to look forward to. I believe we're going to have a deep dive with Foamy Guy tomorrow. I believe there will be some various variegated desks of Lady Ada tariff talks kinds of things, eyes on NPIs created over the weekend, so keep an eye out. And then we'll be back on Wednesday with 3D Hangouts, Show and Tell, Ask an Engineer, and more. So thank you, everyone, so much for stopping by. For Adafruit Industries, I'm John Park. This has been John Park's Workshop. Bye-bye.
Thank you.